So welcome to 2.5 in calculus. I would say buckle your seatbelt because this is a pretty long explanation. But to the right we have the quadratic function, and they are to give you, shift to left 4, left 2 down 4 is our vertex, and you can tell that it's a vertical shrink by a factor of 1/2. And if we were to actually find g prime of -4, we can use calculus to figure this out. Like if we were to rewrite g of x, I might be doing part 2 or a later part anyway, but I might as well show the work right here. So we'd have 1/2 times the quantity of x squared plus 4x plus 4, minus 4, which is equal to 1/2 x squared plus 2x. You'd have plus 2, but that minus 4 would make that minus 2. So what I'm looking at is g prime of x would equal 2 times 1/2 is 1x plus 2. So then we could actually figure out numerically what g prime of -4 is, which would be plugging in -4 then for x plus 2, which would equal -2. So what does that actually mean? At x equals -4, our slope of the tangent line should be down 2 over 1. I'm trying to draw this perfectly, but please forgive me, that's not exactly a slope of -2, but pretty close. So what does this value actually represent in terms of the graph? This is the slope of the tangent line at x equals -4, which is what I drew. All right. So then we can find the equation of the tangent line that we drew. And we already sketched the graph of it. I knew I was going to do part of that somewhere in here. Now there's two ways of doing this. The first way would be just continuing on since we have the graph and see where it crosses. Otherwise, and what people typically do is find the point and the slope. Well, we already found the slope at x equals -4 is -2. That's right there. And the point is -4 for the x-coordinate. We have to find the y-coordinate. Well, I would probably just go to this equation, although maybe, in hindsight, going here is even more obvious because -4 plus 2 is -2 squared is 4. Half of that is 2 minus 4 is -2. Otherwise, you could probably go right here and say, oh, my point is -4, -2. Whatever works for you. So you may remember from a previous lesson that we wrote y equals the slope x minus the x-coordinate minus the y-coordinate. And that's how I like to write our answer. I strongly suggest you doing that. So now what we can do is we can approximate what a value would be. And this is actually what they used to do to figure out square roots and stuff before calculators. We can now approximate the value of g of -3.9 by using our tangent line. So obviously this is going to be an approximation because, let me go back to my graph, -3.9 would be about right here for my tangent line, and the actual line is right here, so it's going to be off a little bit. But we can get a pretty good approximation by plugging -3.9 into put a little approximate symbol in for the x value in our problem. So -3.9 plus 4 would be 0.1. Well, if you double that, you get 0.2, and 0.2 knew I'd mess up somewhere. This should have been -2. So it's -0.2 minus 2 would be -2.2. a pretty good approximation to the exact answer. Now, what you could do to get the exact answer, because we have a calculator, is we could pull up a calculator and we can actually see, negative 3.9 plus 2, whatever that is, squared, half of that minus 4 will give you the exact answer. Now, the other piece that they're asking for is that the, I guess they actually wanted you to figure out what g of negative 3.9 is. I'll just pull up the answer key. The actual answer is this negative 2.195. And what you should notice from this, and obviously this person's work is a little bit different from mine, but it is the same answer, that it's off by barely, like 5 thousandths. That is it. It's very close to being the same. So what we can do is we can use the tangent line to approximate values of a function. Obviously they'll be off a little bit, but they're close enough that we can use them to approximate. And like I said, they used to do this before calculators, maybe even before your parents' time or grandparents' time, before we started, calculators are part of our everyday life. So what we can do now is look at more difficult problems, to do these types of these premises. All right. So as we look at this problem, you probably are looking at the graph and saying, well, where's the horizontal tangent? Well, if you look at this, it kind of looks like the horizontal tangent is at x equals 1. Well, we can actually find the horizontal tangent by finding the derivative of that function. What would probably be helpful is that you rewrite this as x to the 1/2 power, because then you can bring the 1/2 in front. So 2 times 1/2 is 1. Subtract 1 from 1/2, you're at negative 1/2. And then the derivative of x is 1. The derivative of 2 is 0. No need to write that down. And you have horizontal tangents where the derivative equals 0. Now, as a reminder, x to the negative 1/2 power is the same as 1 over the square root of x. So I can add 1 over. So I could just multiply the square root of x to the right side. 1 times anything is that thing. So x must equal 1 because you square both sides. That's how I would do the algebra to support that answer. Anyway, so what about where g prime of x is less than 0? Well, what does that mean? If we have a negative value, that means that g of x needs to be decreasing. Well, let's look at the graph. Where are we decreasing? On the interval, and again, I'm going to use a bracket. You might have another math teacher that uses a parenthesis instead. But it's going down and to the right from positive 1 to infinity. So what about where g of x is increasing? Okay, well, if g prime of x is positive, I already gave you the answer. G of x is increasing. And that's only on the interval from 0 to 1. It's going up and to the right from 0 to 1. Now the reason why we can't go to the left of 0 is because we can only square root non-negative numbers. So this function is only defined where x is greater than 0. What about where the slope of the tangent line is equal to 2? Well, we already did the back end work of this, and that was up here of finding the derivative. So as we look at that, I'm going to rewrite the derivative as how I mentioned x to the negative 1/2 power is the same as 1 over the square root of x. And what we want to do is see where this function is equal to 2. So the slope of the tangent line is equal to 2. So now what I would do is, again, just algebra, add 1 over. And then I would cross multiply. I don't know if that's helpful for anybody, but you'd have 1 over 3 root x. And then divide the 3 over. And then you can solve this by squaring both sides. So x will equal 1/9. I would say that that is going to be the slope. And you can look closely at x equals 1/9, barely in here, that you probably have a slope of up to over 1 right in there. So it definitely should be a fraction. Plus that's the only time that it has a positive slope, is between 0 and 1. And when they ask for the equation of the tangent line at x equals 4, I'm tired of this color, I'm going to switch over. It's important that you have the point and the slope. So what I would do is find, first of all, the point first. So when x is 4, what's the y-coordinate? Well, you have two options. Because they give you the graph, you can go to 4 and see what the y-coordinate is. Otherwise, you can plug it in here. Well, the square root of 4 is 2, times 2 is 4, minus 4 is 0, plus 2 is 2. Now what I would do is find the slope by plugging in the square root of 4 into the derivative equation. And you can see that would be 1/2 minus 1, which would be negative 1/2. So now I can write the equation. So y equals the slope, x minus your x-coordinate, plus your y-coordinate. Something like that. And they also ask you to draw the graph on the grid above. So that's another reason to do this in blue, is the slope was down 1, right 2, if I remember correctly. So that blue line would be the equation of the tangent. Something like that. Sorry, kind of got busy there. So feel free to pause the video before moving on. I think I can get some more problems done in the time limit. And what we're doing is we're looking at the derivative of h. So this is a table of values, and we can answer these questions. Now notice in the problem, it also talks about the zeros indicating the table, the only zeros. So if this is the only zero, and this is another 0, then any value to the left of x equals -2 has a positive value. So what does that mean? Well, if h prime of x is positive, greater than 0, then h of x is increasing on the interval. And again, I'm going to assume it's defined everywhere from -infinity until we get to -2. But then again, past 7. I need to be careful because it's negative to the right. So that is not true. Should have paid close attention to that. So what about where the derivative is less than 0? That means h of x is decreasing. And that would be from -2. Even though the graph goes back to 0, on either side, they're negative values. So it stays negative throughout. Okay. If it said open intervals, maybe you could say -2 to 7, union 7 to infinity, but I like this answer better. So where would we have a relative max? Well, a relative max, if we're explaining, the derivative must change from positive to negative. And the reason for that is if the derivative is positive, it goes to increasing. Negative is decreasing, so it has to have a maximum there. Well, where does that happen? Over here on -2. You see how it goes from a positive value to a negative value? I don't like how I wrote that. But at x equals -2. I think I have enough time just for one more. A relative min, same thing, but it must change signs, so the derivative must change from a negative to a positive. As you look at your table, it never goes from a negative to a positive, it goes from a negative to a negative, so there is no relative min. And again, I'm at the end of my video, so I need to stop, and I'll see you on the other side. Feel free to pause and write down anything you need to.